Hello. The difference between people who are good at math and people who are not good at math is people who are good at math have played around with it enough to find, well, cheats, easy ways of doing things. It's not that they're intrinsically smarter or that they have more math ability, but they've found easier ways to do it. And when I've shared what I've come up with other people who are good at math, they say, well, yeah, that's the way I do it. Unfortunately, these methods are not taught in schools. So today's lesson is going to be as many of the mental math tricks as I can come up with. All right, and there are a lot of them. First, let's look at adding. Let's add a column of numbers. 7, 8, 7, 9, 6. I'm just pulling them out of the air. All right. One of the things we're taught is to look for tens. Well, there isn't anything really that combines there to make 10, right? However, one secret is that we can break numbers up. Okay, we can make this 6, a 3 plus 3, and group it with the 2 7s. That gives us 20. So now we have 8 and 9. 9 needs a 1, which we can subtract from the 8. So that gives us another 1. And we have 7 left over. 2 and 1 is 3. So the answer is 37. This is a lot easier than going 7 plus 8 is 15, plus 7 is 22, plus 9 is 31, plus 6 is 37. Once you get used to doing this type of thing, you can do it in your head and you can do it lightning quick. Let's look at another example. Six, 3, 7, 9, 2, 5. Okay. Here we've got a 7 and a 3, which makes 10. What's left over doesn't really fit together well, or does it? 5 and 6 is 11. This 9 needs that extra 1. So combining these three gives us 20. And then all we have left is the 2. So our answer is 32. This can be done with multiple digit numbers. Let's add those. All right, first thing we do is cover up everything but the one we're looking at. Now we're adding 3, 9, 8, and 7. Okay, we can put the 3, let's change the 3 into 2 plus 1, because this needs a 1, and this needs a 2. So that way we can get 3 done. 3 number is gone. We get 20 here, and we have 7 left over. We could have also done the 3 and the 7 together and then taken 1 from the 8 to the 9 and still gotten the same 27. All right. 5, 4, and 1 is 10, and 2 and 7 is 9. 1, 2, 3, 4, 8, 9. Five, 9, 3, 4, 7, 2, 8, 6, 6, 5, 4, 3, 9, 7, 9, 7. Oh, that makes it too easy. 9, 7, 9, 8. This is 10. 8 needs a 2. We can take the 2 from the 3 to make another 10 and have 1 left over here. 8 and the 2 make 10. 9 needs a 1, we have a 4 and a 3. So let's take, make that 3 a 2 plus 1. Okay, we can group the 1 and the 9 to make another 10. And then we have 2 plus 4. All right, 9 needs a 1. We'll take one of these. 7 and 2 make another 9, so we can take the other one. And then we have 5. 9 and 1 make 10. Now we have 6, 7, 5, and 1. 7's the largest number, and that one needs a 3. 5 is 2 plus 3. So let's cancel that 3 and group it with the 7. Now we have 1 and 2, which is 3, plus 6, so that's 9. And then we have 2 left over. There's our answer. Okay, let's look at adding two-digit numbers. This is one way you can do this in your head. Okay, let's look at 15 plus 17. Okay, what we've got there, I wish this actually was 15. Let's make it 15 plus 2. Because I know 15 plus 15 is 30, right? So 30 plus 2 is 32. So the trick to this is to figure out what number you want it to be, and make it that. Find a way to make it that. So we add an easier number. Let's do another one. Let's do 37 plus 28. I wish this 28 was a round number. Let's make it 30. It's 30 minus 2. Okay? 37 plus 30 is 67. Minus 2 is 65. How about 63 plus 29? Okay? At 29, we're going to go 30 minus 1. 63 plus 30 is 93. Minus 1 is 92. Another way to do it is to simply add the tens column first and then the ones column. When they teach us math in school, they teach us how to do it like this. 6 plus 7 is 13. Carry the 1. 3 plus 1 plus 1 is 5. When we're doing it in our head, we're limited as to how many numbers we can hold at the same time before we start losing it. So what we do instead, when we're doing it in our head, is to split things up. 37 plus 10 is 47, plus 6 is 53. Now this is slightly longer when you write it, but if you do it in your head this way, you can feel that it's easier to do. All right, let's have some examples. $53 plus 49. You get it? It's 102. 53 and 40 is 93. And 9 is 102. 68 and 14. You get it? 68 plus 10 is 78, plus 4 is 82. And one more time. $37 plus 29. 37 plus 20 is 57, plus 9 is 66. When you have one that ends in 7, 8, or 9, it's easier to do it. 29 is 30 minus 1. 37, 67, minus 1, 66. But this method works primarily when you have a 7, 8, or 9, because otherwise you're subtracting too much and the numbers become big. And one thing that speeds things up is to work with the smallest numbers possible. If there's any way to make a smaller number, do it. All right, this also works with subtraction. Okay, 37 minus 30 is 7. This becomes a plus 1 because the negative carries over. Okay, so that's 8. We can also subtract tens and then ones like we were doing before. Okay, 64 minus 16. Okay, 64 minus 10 is 54. Minus 6 is 48. Getting a little ahead of myself. I've got one more adding trick to show you. It's adding columns. For example, for adding these numbers, we can do the tens thing for this side. That's 10. This needs a 2. We've got the 2 here. So that's another 20. And 3 plus 1 is 4. Okay, now let's look at this. 1, 2, 3, 4 fours. We can make the 5 into 4 plus 1. 1, 2, 3, 4, 5 fours. 5 times 4 is 20. 1. Let's look at what's left. 1 and 2 is left, so that's 23. 23.4. Okay? So if you've got a bunch of the same number and some that are close, you can make them into that and then use multiplication rather than addition. All right, I want to talk about subtraction for a little bit. I think it's taught wrong. One of the things that it relies heavily on the way it's taught is borrowing. And to be honest, I suck at borrowing. And if you talk to people who are good at math and have come up with ways to do it in their head, they don't borrow. Okay, they figure out a different way. Let's look at 22 minus 17. So instead of thinking about 22 apples and 17 of them are taken away, let's think about a hole. The hole is 22 feet deep. If we dump 17 feet of dirt in it, how deep is the hole? Okay? Well, first thing we do is we dump 2 feet of dirt in it. Now we know that this is 20. Right? And since we dumped 2 feet of dirt in it already, this is 15. 20 minus 15 is 5. So once we dump the rest of it in, we're going to have 5 feet left. All right, when I think about subtracting, I'm thinking about filling in a hole. Another way to look at this is a number line. All right? For subtracting, what we're doing is trying to figure out how long this line is. Okay? So again, what I do is I go, okay, it takes 3 to get here, to get to 20. And then we got another 2. Obviously, my drawing is not to scale. So 2 plus 3 is 5. So the distance is 5. Those are the 2 ways I think about it when I'm doing subtraction. I don't borrow much. Sometimes when I'm in the middle of something and that's the only way to do it. This is the way people do things in their head. Because when you're borrowing, you got to keep track of 2 different things. You got to keep track of what this number has become, and you got to keep track of whether you added 9 or 10 to this one. And especially if I have a lot of places that have to serial borrow, I lose track of that. Okay, I want to show you another of my favorite tricks for subtracting from round numbers. Let's look at 10,000 minus 8739. Rather than borrowing and ending up with 9s and 10s there, I just subtract 1, okay? This makes the problem all 9s. Now it's easy to subtract, right? 1, 2, 6, 0. Now add that 1 back in. 1, 2, 6, 1. You can do this in your head. I was showing this trick to a student, and they asked me, what happens if this isn't quite an even number? What happens if we have this? Thought about it for a minute, and I said, let's subtract off 11. That gives us our 9999. We can do our same 1, 2, 6, 0, but then we add the 11 back in rather than the 1. What this means is you can make this top number anything you want by subtracting off bits and adding them on later. Okay? So you can make this number nice. The trick is that you need to make this nice without making this ugly. Okay, because, you know, the easiest way would be to change this to 739. but then you have to subtract that off. You have to subtract off the 261 to get there, and that's the ugly part. Okay? Let's do a couple more subtraction exercises. First we'll do the 2-digit, and then we'll do the big numbers. Okay, let's take 73 minus 28. What is it? It's 45. I'm changing the 28 to a 30 minus 2. Okay, that gives us 73 minus 30 minus 2. To get rid of the parentheses, we multiply by minus 1 on both of them, and we get this. 73 minus 30 is 43, plus 2 is 45. Okay. $23 minus 16. Did you get it? It's 7. What I did on this one is I went, okay, 16 to get to 20 is 4. And then 23 is 3. 4 plus 3 is 7. Think about that hole. Look at a hole. It's 23 deep. You put 3 in here, and that makes it 20. So now 16 minus so now 20 minus 16 is 4. 4 and 3 is 7. All right. $46 minus 17. Did you get it? It's 29. I use this as 20 minus 3. So 46 minus 20 is 26, plus 3 is 29. Or you could go, it takes 3 to get up to 20, and then you got 26 here. So that's 26 plus 3 again. Okay. This is 4. 38 is 40 minus 2. So 42 minus 40 is 2, plus 2 is 4. Or you could think of the number line, 38, 42, halfway through is 40. It takes 2 to get here and 2 to get here. So 2 plus 2 is 4. Now let's look at some of those big numbers, those big round numbers. 20,000 minus 18, 792. So we subtract 1. We get 19,999. 18,792. So 7021. Now we add that 1 back in, and we get 1208. $41,000 minus 37,596. Okay. We're going to subtract 1. $40 minus 37 is 3. Now we just have the 9s. 403. Add back that 1 back in. 3404. And 1 more. In this case, because of that 23, we're going to take out 24. All right, 50 minus 49 is 1. 9 minus 5 is 4. 2, 7. And we add in the 24. 27. 47, 51, 1451. Okay, let's do multiplication next. I have a confession to make. I don't have the multiplication tables memorized. I just pull up the number as I need it. All right, and I'm going to show you my technique for doing that. I'm going to use 8s because 8s are a pain in the butt. All right. 1 times 8 is 8. 2 times 8 is 8 plus 8, which is 16. 3 times 8 is 2 times 8 plus 8, which is 16 plus 8, which is 24. 4 times 8 is 2 times 2 times 8, or 2 times 16, which is 32. 5s have a fun rule to them, okay? So I'm going to show you 5s, a trick with 5s. You can multiply any number by 5 or divide any number by 5 with very little effort, all right? Here's the trick. 5 is 10 halves. Yes, this is one time when one of the few times when fractions will make things easier. Okay? So what we have is if we have any number times 5, we have that number times 10 divided by 2. So to multiply any number times 5, we just divide it by 2 and multiply by 10. Okay, we were doing 8s, so let's look at that. 8. All right. We can do these in any order we like. Okay? If it's straight multiplication and division, order doesn't matter. So what we can do is we can do 8 divided by 2 is 4, which gives 4 times 10 is 40. All right? But you're like, yeah, I know that 8 times 5 is 40. I don't need to do this goofy stuff. However, it works with any number at all, any number. So let's look at more difficult numbers. Let's do 5 times 2, 4, 6, 8. All right? Half of 2, 4, 6, 8 is 1, 2, 3, 4. And then we tack on the 0, and we have our answer. 5 times 2, 4, 6, 8 is 12,340. Okay? So any number at all. Doesn't matter how big. In fact, the bigger it is, the more you save by doing it this way. So let's look at another number. 3, 4, 5, 6, 8. I'm just pulling numbers out of my head. All right, we cut this in half. All right, 3 is not has that as an odd number, so it causes issues. But let's look at 34. 34 cut in half is 17. 56 cut in half is 25, 26, 27, 28. And 8 cut in half is 4. We stick a 0 on the end. 5 times 34,568 is 172,840. So this works with division as well. Division's even easier for 5s. We've got that 5 is 10 halves, so when we divide by 5, we invert and multiply. All right, so when we divide by 5, we double the number and move the decimal. So let's do 1, 2, 3, 4 again, or 2, 4, 6, 8 again. Okay, 2, 4, 6, 8 divided by 5 is we double the number. So 4, 9, 3, 6. And then we move the decimal here. So 2, 4, 6, 8 divided by 5 is 193.6. Okay? We'll see this more when I'm talking about division. All right, so back to our multiplication table with 8s. So now we have proved a number of ways that 5 times 8 is 40. Okay, so 6 times 8 is 5 times 8 plus 8. So 40 plus 8 is 48. Seven times 8 is 5 times 8 plus 2 times 8. So 40 plus 16 is 56. 8 times 8 is 5 times 8 plus 2 times 8 plus 8. So 56 plus 8 is 64. This one, I'll admit that I have this one memorized because it's a perfect square, and those are handy to have memorized. Okay, 9 times 8. 9 times 8 has 3 different ways I can tell you to do it. All right, 9s have tricks to them like the 5 had a trick to it. Okay, the first way to do it, 9 times 8 is 10 times 8 minus 8. So 10 times 8 is 80, minus 8 is 72. So that's one way. All right, another way uses your hands. You can multiply on your hands. All right? Put up your hands. Now, count them. 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th finger. So we put that 8th finger down. Now we have 7 on the left and 2 on the right. That means the answer is 72. Let's do that again with a different number. All right? So let's do 7 times 4. So put down the 4, we got 36, which is 4 times 9. All right, there's another way to do it that you can do if you don't have your hands free. I had to do some writing to set this one up. All right, 1 through 10 times 9. Ready? Here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You count down and you count back up. Now, if you notice, if we add the tens digit and the ones digit together, we get 9 for all of the numbers. All right. Another thing to notice is that the tens digit is always the number you multiplied minus 1. Okay? So if you're multiplying times 9, the tens digit will be n minus 1, and the ones digit will be 9 minus this number. 9 minus the tens digit. So 8 times 9, 8 minus 1 is 7, 9 minus 7 is 2. 8 times 9 is 72. Okay? We did 8 times 4 for the other one, or 9 times 4 for the other one. 9 times 4. 4 minus 1 is 3. 9 minus 3 is 6. 36. So here are the tricks for multiplying times 9. All right? So now let's look at multiplying bigger numbers. We've talked about multiplying single-digit numbers. Let's look at multiplying larger numbers. All right? Let's multiply 37, let's make it 34 times 12. All right? Now you remember how I made simple numbers when we were adding? We can do the same thing when we're multiplying. We can split that 12 up. Okay? That's the same as 34 times 10 plus 34 times 2. 340 plus 68 equals 408. So the answer is 408. Okay? This is really the same thing as you would be doing with the normal method. You'd go 2 times 4 is 8, 2 times 3 is 6. That's our 68. Then you'd put a 0 here because it's the tens column. You go 1 times 4 is 4. 1 times 3 is 3. 340, that's this column. and then you have the 408. But by breaking it up like this, you can do it in your head. All right? Let's look at another one. Let's look at 27 times 32. All right. (27 times 3) plus 27 times 2. All right. 25 times 2 is 50. And then breaking the 27 up into 25 and 2, so that's 50 and 4. So 27 times 2 is 54. 27 times 3 is 54 plus 27. So that's 70, 81. So now we're going to add, and this is we multiply by 3, but it's actually a 30, so we add the tens place on there. So now I can add 810 plus 54 pretty easily. It's 864. Because the 8 doesn't add into here, and it's just 1 plus 5 is 6, and then the 4 and 0 is 4. Now remember when we were adding and subtracting and we would make it an easy number and then change things? So we're going to do that again. Let's look at 23 times 19. I don't want to do 23 times 19. However, I can change 19 to 20 minus 1. Now we've got 23 times 20, which is easy. We're just doubling the 23 and adding a 0. So that's 460. Minus 23 times 1, which is 23. So it's 460 minus 23. So we go 460 minus 20 is 440. Minus 3 is 437. And we didn't have to touch any 9s. Okay? So if instead of 19, if this was 18, then we would be subtracting 2. Well, we know 2 times 23 is 46. So now our answer is, we got the 400. 60 minus 46 is 14. 60 minus 4 is 20. 20 minus 6 is 14. So our answer would be 414. Okay? Another thing that I run across a lot is people who are not aware that you don't have to handle zeros. So if you've got something like this, you don't have to go 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That would make me crazy. Okay. I would be insane real shortly. Okay, so what we're looking at here is we've got 25 times 1,000. And we're multiplying that by 4 times 1,000. Okay? So, like I said earlier, we can multiply in any order we want. And what I want to do is I want to do the 25 times 4. That's 100. Now when we multiply by something with zeros, 110 1,000, whatever. We just count the zeros. 1, 2, 3, 4, 5, 6. And we get 10 million, or 100 million rather. We get 100 million. Okay? You don't have to put the zeros down. Don't put the zeros down. It wastes a lot of time. And time is important on the ASVAB because it is a time test and most people fall behind on the math because, get things wrong on the math because they didn't have time to do the problem. So the faster you can get things done without rushing yourself into mistakes, the better off you are. So practice some of these tricks that I'm giving you so that they become more second nature. And that will help you do a lot better because you're moving faster. All right. Let's start division. Okay. So division works similar to multiplication, except it's backwards. All right. So let's say we are dividing. Let's do okay. First thing we do is we cancel zeros. We get rid of the zeros. We don't care about the zeros. And so now we have 24 divided by 6. On that one's easy. That one's 4. So this whole thing is equal to 4. Which we could do because we canceled. Okay? When you're dividing something, you can divide the same on the number on the top and bottom by the same thing. Let's look at another example of that is not quite so obvious. All right. Let's look at 273 divided by 9. Okay. So it's just 270. That would be easy to cancel, but it's not. So I'm going to take 3 out. We're going to divide both top and bottom by 3. And that's going to give us 3 on the bottom, 9 divided by 3. Okay, 27 is divided by 3, and you get 9. And then the 3 divided by 3 is 1, so you get 91 divided by 3. From here, you can split that up. Ninety divided by 3 plus 1 divided by 3. All right? Dividing both of these by 3, you get 30 over here. 30 over 1 plus 1/3. So you get 30 and 1/3 as your answer, without actually having to do the long division. It works. Okay. But you can do this easier in your head. All right. So canceling is a very powerful thing that you can do. Another thing is, remember I was talking about how you can ignore the zeros and just take care of them at the end with multiplication? You can do the same thing with division. You can look at like 9,000 divided by 3. I'll just go 9 divided by 3. 9 divided by 3 is 3, and then 1, 2, 3 zeros. All right. If you doubt this, we can multiply by 3 and get our 9,000 back. Okay? So So just pay attention to the numbers that are not 0. Let's look at long division. All right. Long division is something that a lot of people don't remember if they learned it or never learned it in class, whatever. I'm going to divide 1, 2, 3, 4 because I'm running out of 1, 2, 3, 4, 5 by 67. Okay? 1, 2, 3, 4, 5 over 67. This is one way of writing division that we see a lot. How you translate it is the guy on the top goes into the house, while the guy on the bottom stands guard outside. That's something that pretty much everybody in the Army can identify with. All right? So we write it like this. The big pile is in the middle, and the number we're cutting it into is on the side. Because yeah, division is basically you've got a bunch of stuff, and you want to cut it into individual piles. All right. So this is the big pile of stuff, and this is the number of individual piles. So now we're finding out how much is in each pile. All right. So you look at the 1, 67 does not go into 1. You look at the 2, 67 does not go into 12. You look at the 3, 67 does go into 123. Okay, so we're going to put our first number here, which means that our answer is going to be in the hundreds. Okay, so I look at this, I look at the 12, and I look at the 6, and I say, okay, 6 times 2 is 12. But we're going to be multiplying that 7 times 2 as well, and that gives us 14. So that would give us 134, which is too big. So we stick with the 1, okay? All right. So we subtract that off. We got 56. Then we bring down the 4. All right, now we have to put it into 564. Well, 564 is kind of a pain in the butt. Let's see. Let's check. Always check the 5s, because 5s are easy. Remember, you just cut it in half and add a 0. So 5s would be 335. All right, 335 is a lot less than 564. So it's going to be quite a bit over 5. So I'm going to add 67. 4. So we got 402. So if this one's 5, we've multiplied it times 5. We've got another one, so that's times 6. We'll add another one. So that's 7. We'll add another one. So that's 8. Okay, 536. So that's 8. So 8, so we're going to subtract this off. We got 64 minus 36. So it takes 4 to get to 40, and then we got 24, so we got 28. I don't want to borrow. All right, so now we have 285 divided by 67. All right, we had 335 as 5. So this is less, so we want to subtract off 1. So 4 times 67 is, okay, 135 minus 67 is 33 to get to the 100, and another 35, so that's 68. All right, so 4 is 268. All right, 85 minus 68 takes 2 to get to 70, plus 15, so 17. All right, now we've hit the decimal point here. Anything beyond this is a fraction. So we're going to cut this short by taking the remainder here and putting it over this number here. Okay? So this one goes on the top and this one goes on the bottom. Because this is actually saying 17 divided by 67, and that's what we have here, 17 that we're trying to divide by 67. So 184 and 17 67ths. All right, so this is kind of the review for long division. All right. One of the most common things we do in math is divide by 2. And when you're dealing with even numbers, that's easy. We have 2, 4, 6, 8 divided by 2. We just look at each one and divide by 2. 1, 2, 3, 4. All right, but it's not so easy once you mix in odd numbers. Okay, let's look at an odd number and divide it by 2. 7. 7 divided by 2. Once again, I go, well, what do I want it to be? Okay, I'd like this to be an even number. So I'm going to subtract 1 off of that. I'm going to make 7 6 plus 1 and divide each of these by 2. 6 plus 1 is 3. And this, you can see, is a half. So it's 3 1/2. We can continue to do this with larger numbers. For example, let's take a not much larger number, 17. We want it to be even, so we go 16 plus 1. 8 1/2. Okay? And bigger numbers still. Okay? 13 divided by 2. We'll make this a 12. And plus 1. We'll push that 1 down by the 5. It's kind of like borrowing, but in reverse. Instead of 5 saying, hey, 13, can I have 10 so that I can subtract something? 13 is saying, hey, I want to be a 12. So here, take this stuff. So 12 divided by 2 is 6. And we have 15. We want 15 to be 14. So 14, and we push the 1 down by 7. 14 divided by 2 is 7. Now we have 17. 17 wants to be a 16. So we make it a 16 and push the 1 down here. 16 divided by 2 is 8. 19. 19 wants to be 18. So we change this into 18 plus 1. 18 divided by 2 is 9. 1 divided by 2 is a half. So 13,579 divided by 2 is 6,789 and a half. Let's look at another example. Let's mix together even and odd numbers. How about 123,479 divided by 2? Okay. 12. 3 3 wants to be a 2. 2 divided by 2 is 1. 14. 7 wants to be a 6. 19 gives us 9.5. Okay? The only thing that can throw you on this one a little bit is if there's a 1 in the middle of the number somewhere. Okay? 3. 3 wants to be a 2. That gives us a 1. 12 gives us a 6. 1. Okay? 1 is odd, and if we subtract 1, we have 0. Let's do that. We'll move the 1 over here and make this a 0. So this is a 0. 16 divided by 2 is 8 and 1. Okay? The other option is over here. Is instead of looking at the 1 by itself, we can group it with the 6 and make it 16. 16 divided by 2 is 8, but we have to be careful of putting the 0 here. Because it's 08. Because we didn't push the 1 down, we grouped it. Okay? So that's the only tricky part on this one. So this is how to divide by 2s. If you want to do it in your head, $47,529 divided by 2. If you're going to do it in your head, there's a couple things you need to do. First is you check to see if this number is even or odd. Second is you check to see if the number up 1 is even or odd. Okay? This one's even and there's nothing in front of it, so we just divide it by 2. 7 is odd. So we're going to subtract 1 to make it 6. And then we're going to check to see if this is even or odd. And since it's even, we just go ahead. 6 divided by 2 is 3. Okay, 5. 5 is odd. So we subtract 1, make it 4. But since this 7 is also odd, we add 10. Okay, so we have 14. That makes 7. 2 is even. But since 5 is odd, that means there was a 10 that got passed down to it. So that makes it 12. So this is a 6. And then we have a 4.5. So the rules there are, if the number is odd, subtract 1. If the preceding number is odd, add 10. And if we just do that, we just walk through it, and we don't have to keep track of which one's pushing and which one's not. So I know this has been a fire hose of information towards you. So please feel free to pick up what you can, incorporate it into how you think and how you do math, and then come back and get some more. This is like 40 years worth of knowledge that I'm kind of pushing at you in less than an hour. So don't feel bad if you can't pick it all up. All right, the next lesson is going to start with the material in the book, and we'll be looking at ratios. See you tomorrow.